This lecture is being brought to you in part by the generous gifts of these sponsors.
I'm glad to be here. I'm overwhelmed with the reception I've had at IHMC. I learned so much in the few days I've been here. I put this model of Gutenberg's press as a symbol of enlightenment. And that's what I think that the computer is doing to us, enlightening our society and bringing us to a new level. What I'm going to talk about is what I think is a model that will help us get there faster to the higher level. Now, my first job out after NC State was at the Pentagon. And let's see here. I had an office right here where the parking lot joined. It was underneath the parking lot. You don't realize there's a 3-story room underneath the parking lot. And it had never been used until, I guess, about the time that I went in there, because they'd built some primitive offices, and on top of the primitive offices, they built the mezzanine on top of that. And on top of the mezzanine, they put us IBMers there. And so we had, along the roof, we had, where the parking lot came to the building, we had a gutter there because the water would come down the side of the building and come inside the building. So anyway, it was really primitive. And, you know, the contract IBM had was, they used to call it a body shop mechanism. There was 6 programmers there, and I guess there was a manager we never saw. And we had to get, I guess we scrounged to get some tables, and then I remember we found some boards and some bricks and made our bookcase there. It was incredibly primitive. Well, anyway, I just loved the objective, which was to put all the information inside the computer. And we worked on the formatted file system, which was given by this genealogy. See, the first database management system, I guess, goes back to 58. But we're down here. Oh, if I get the buttons right. Shoot. I've got the thing upside down in my hand, I guess. Shoot. Am I going forward or backwards? I guess I'm going back. Okay, now. Well, we worked on the formatted file system, and what it was is people had written the formatted file system before, so it seemed that, well, they got the new 1410, so we're re-implementing it on a new hardware. And so I got, write this language, write this retrieval system. It was bizarre, the instructions we had. But anyway, I loved it. And I had one big feather in my cap. I wrote a retrieval program where you could walk up to the computer console. You know, here you had 100,000 character memory. I mean, that's about a third the size of a PC. You know, the computer we were working on. Well, anyway, I had it where you could walk up and interrupt the program, roll the program and process out, roll this retrieval program in, then you could ask a question. Well, it turned out about 10 days after we put this online, Bobby Kennedy phoned over to the National Military Command Support Center and asked how many sorties were over Haiphong Harbor within the last 90 days. So that, He had to use a circle search and have the list of sorties and where they dropped the bombs. Anyway, they got their answer immediately, and Bobby Kennedy wrote the National Military Command Support Center a thank you note, and then Commander Carter said, "Hey, look at this, look what you did." Anyway, so that was my big thing. Anyway, but after 15 months, I had my first sit-down talk with my manager, and it didn't go well. So he had a listing in front of him about that thick, and he said, "We have a real big problem." And he said, "You've written over 50% of all the code for the 6 men in the team. We just can't have that. We got to spread the work around." So he gave me a job, which was how to share a common disk drive between 2 mainframes. This is electrical engineering thing, not mine. There was absolutely no resources. He was just saying, "Sit at your desk and do nothing," is what he was telling me. Well, anyway, after about 2 weeks of that, of being just out of my mind, I'm not going in there on the weekends, not going in there in the evening, I pick up the phone on my desk. It was the first phone call I ever got at the Pentagon. It was my old boss saying, "Will you come back to NC State, to the statistics department, and rewrite your programs, the regression analysis of variance programs that I wrote as a grad student?" And he said, "All my programmers have left, and we're getting these mainframes." Just the IBM 360 was coming in. So I took the bus down there that Saturday, and they interviewed me, and I went to work for NC State, starting to work on the SAS language. And this is SAS 76. I started in 66. This was on the 10th anniversary. This was incredible. This was like the 3rd big release of SAS. But we decided to form our own company. And we left NC State, formed SAS Institute. And I was there for 3 years. And then I left it, and I said to myself, well, it was got to be a groupthink type of thing. It was just, I was no longer a designer anyway. But anyway, I went to work I decided I'd build this machine. Now, this is a prototype machine that I built at the university that would scan lumber, see the knot holes, and then figure out how best to cut the lumber up to get the least amount or most amount of value out of the lumber. So anyway, I went into a warehouse and had a little air-conditioned room in there, and I got some conveyor belts, and I got the computer from Motorola. I got a scanner. When we built this machine, we had to build our own scanner. This was an individual fiber optic cable going to photo sensors, 128 of them. But by the time I was starting this, there was you could buy cameras with an integrated circuit in it. It had the whole camera in it. Anyway, this was just an unbelievably expensive thing. I never did the arithmetic. So I blew $150,000 of my $340,000 in 1 year. And the biggest expense was hiring engineers. So I said, this is not going to go. So I decided I'll build a new language. And it turns out there is this book about computer languages and how to build compilers and whatever. And it's somewhat inspirational, Slaying the Dragon. But I came up with a model. I'll get to the next slide. I read this guy Backus. He was the inventor of Fortran, and Knorr and Backus were the 2 people who put together the ALGO language, which was supposed to be the language for scientists to use. It's no longer used at all. But Nauer was the editor. But the two people came together and they said, well, we've got a meta-language for describing languages. And they gave it the name the Backus-Naur form, BNF. And then I read this thing about the BNF of BNF. Well, here you've got a description that would, I had the grammar of grammar with the BNF of BNF, if BNF is a grammar. So I thought this was so exciting. So I started working on what is now called a syntax-directed editor. Essentially, you always had one finger in the grammar and one finger in the object. And as you could add new, let's say you're editing an expression, you could add it into it an expression of a number. You could add it a number or a reference to a number or another expression that returned the number. A function returned the number. So I thought that this was just mind-blowing because, say you had one finger in the grammar, one finger in the object, and you always knew what you were looking at. And what you were editing, it would always give you only the correct things to edit for that particular object, a choice of grammatical units. Well, so the grammar of grammar could define itself since it was a grammar. Then it would define the grammar of a language, X, for example. Then that would define an object in language X. So it was a way of having a definition of everything. And I thought that's a marvelous idea. Maybe only Tony Barr feels that way, but that was my feeling. Well, so self-definition is actually, a lot of people are intrigued by it, and this is straight from the start of the Bible. Moses asks the burning bush, "Who are you?" And he says, "I am that I am." Couldn't be any more awesome than that. And then here is Polacek, a Czech who came to this country at the age of 19 as a wood carver, and then somehow got into a university and studied sculpture. And this is man carving his own destiny. He has a lot to say about it, how was his struggle to become the man or the sculpture that he became. It was a very cathartic thing for him to do this sculpture. This is down in Winter Park. Well, anyway, here's a drawing by M.C. Escher, who was a Dutch mathematician who did a lot of drawings which had unusual geometric representation. Anyway, I just thought this girl's drawing herself. Well, she's a drawing itself. And I was intrigued by Walter Isaacson's quote. He said, perhaps Benjamin Franklin's best invention was himself. Because he set out with his buddies, and he started this Junta Society for self-improvement, how he was going to perfect his character, his language, his writing, his public service. So, anyway, self-definition. And perhaps here's the ultimate one, is life itself is self-defining. We got the gene in there that controls the exact replication of a cell. Well, so much for self-definition. I went to a talk. I gave a talk, I guess, and they invited me to a Christmas party over in the Department of Clinical Statistics at the University of Florida. I'm sitting down to this professor, and so what did I say? So I said to him, well, I was just reading this book about Kurt Gödel. And Kurt Gödel was the most famous mathematician of the 1900s. And he got famous at the age of 22 in Vienna, Austria, I believe. by coming out with Gödel's incompleteness theorem. No system can be consistent and complete if defined similarly to Principia Mathematica. Well, this has shook the mathematics world. And some people interpret there is no truth. Now, I actually said, I had this conjecture. I said, well, I wonder if anybody's ever written a paper on postmodernism that believes, that's the school that believes there isn't any absolute truth, and Gödel's theorem. And I got a PDF come up, Gödel's theorem and postmodernism. So people did put that together to justify the fact that there is no truth. Well, it's an obscene idea, right? That there is no truth. So the professor turned out he was the former head of the Department of Clinical Statistics at FSU. And he said to me, do you know about concept maps? He got excited and he said, excellent way to teach. I'll show you. And he gets a napkin out and starts drawing circles. You label this, each one of these circles is a concept. You draw lines, all the connections between the circles, and those are the connections. And the home of the concept map is right here at IHMC. So I was intrigued by Joseph Novak's teachings. And actually, he wrote a book, Learning How to Learn, which is how children learn simple concepts, and then they learn more complicated concepts, then they learn more complicated concepts, putting the concepts to build their view of the world. So this to me is a very interesting thing. Is we must have inside our mind for every concept some little bit of nerve cells that represent that concept. Because it's in there, right? We know what a woman is, what a man is, what a car is. So anyway, that is probably one of the reasons why I'm here today, is because I got fascinated with this thought. And here's a concept map. And I guess he was using this for his book, Teach Less, Learn More. And this was, anyway. Here's a more, I think this comes straight off the IHMC website. This actually reminds me more of a mind map, because a mind map has this classification system, a taxonomy. Here is the mind map of Leonardo da Vinci's mind. Now, the concept map, this only has a taxonomy. It's the only way you can do things inside of the mind map. But the concept map from IHMC has connections between concepts, not just their child concepts. Now, I went home from that. I put concept and connection into Google. I got 40 books up. So I said, well, I'll go into Amazon Books and put concept and connection in. And I got 400 books, at least 400, maybe 600 books. So that's the way that academicians want to describe the world. And I thought it was a pretty convenient way for me to think about the world. And why don't we write software in terms of concept and connection? And I actually have variables in there as well. Well, here's the mind. 78 billion neurons. That's a hell of a lot of neurons. And a lot of the neurons are connected to other neurons at synapses. And they make little chemical connections where they can send ions over there, send data across. So now it turns out there's an average of like 7,000 connections for every neuron. 7,000 times 10 to the 14th, 10 times 87 billion comes out to 10 to the 14th. Unbelievable amount of connections that we have in our mind. So our mind is, you could say, concept and connection. And there's the little synapse on the other side, exchanging little chemical bundles that have the information. They're electrically charged, I believe. Well, this is, I have taken that language to heart, and I've used that language to describe my model of reality, which I think could be used for all structured knowledge. The structured knowledge would be running your experiments at IHMC, or it could be doing the payroll at IHMC. Bernie Madoff got away with his big scandal because only like 5 people knew what was going on in the computer. If we all could know what was going on in the computer, it would be hard to get away with these things. Now, I called my thing a model reality, and God gave me the acronym AMOR, so I said, well, I'm going to use that for my logo. Well, here's the first ever time I've revealed this thing in public. And it's so damn stupid, but it took me years to come up with this thing. Now, the deal here is, you see, under connections, we've got name, parent, connections, cases, existence. Then we've got name, parent, connections, cases, and existence. So in the concept of a concept, one of its connections is name connections. And it is a list of connections that's in every concept. Now, I know this is a little hard to take, but this defines every other concept. Now, the cases here are a bunch of meta concepts, and then you get down to the world, and this is the world we live in. Actually, I think this is the way we think. We have this conceptual model in our mind, and the world's out there. And so we have to combine the concept of what's a human with this man or this woman, and that's how we know these things. Now, concepts. This is straight from philosophy. Concepts are either abstract or they're concrete. And concrete concepts can define objects. Like a human, the concept human would define me and you. You might have the concept of, of an instruction, and then there's the instruction, the assignment instruction, the while instruction, the do-over instruction. That is an instruction would be a concrete object because you can write the instruction and then execute the instruction. But the concept of an instruction lives over in conceptual world. I think this is probably the hardest part of the talk to right here. But let's get more concrete. You have the world down here. And I guess I just have to follow this thing according to the. Now, here is the existence concept. And this is perhaps one of the most simple-minded concepts of all. because it's got two cases. One case is called abstract and one case is called concrete. And the abstract concrete, it's got diddly in it. It's an abstract concept, so you can't define other concepts. It's just sort of so that you can say that the parent is the reference to it is a abstract concept. With the concrete concept, it has the addition of variables that will appear in an object, because a concrete concept, well, an object of the concrete concept will have the variables that are in the concept and how you're going to present it. Well, here's where the real world comes in. We've got the concept of the world. Its parent is a concept, is the concept of a concept. And it's got a connection in here. It's connected to the world. This is the only instance that will exist of this connection, which is to the world. And the variables in it are people, organizations, education, governments. And this would correspond to the .org, the .edu, or the .gov of the internet. And this is a concrete concept, because we're actually here, right up here, we're referencing, this is a self-referential reference to the world. So here is a reference to the world. So if you click on this, you would pop into the world. And so you'd be into the world, and you could find your company, or you could find your neighbor in it, I guess. Now, when you have a connection, you have to describe the type of connection. And actually, this is a work in progress, because I realize that you can define so many different types of connections. But here would be the main ones that, a character connection. So you could say the person's name is Tony Barr. You could have a number connection. Now, a number is an abstract type, because there's an incredible number of types of numbers. You can have a discrete number. You can have a real number. Now, the object case is you defined the world, actually, that and so you could put in, when you had the case of an object, you'd have a connection to the world, and then you'd have the set, list, text. Anyway, this is abstract. Well, here is a incredibly important concept. The concept, what is a name? Well, anyway, when you give a name to something, there's really a lot more to it. Wikipedia gives a name to everything, but you go into it, and there's a textual object that says what this name's all about, right? Then just from my experience with SAS, you always needed mnemonics to use in expressions, mathematical expressions. You didn't want to use a whole long title. But when you published the graph, you wanted to use the titles on the two axes. So to do a complete job of describing an entity, you need a title, mnemonic, and description. And if this is done consistently, you'll have everything documented. Because when you're pointing at an object, you got another, at the bottom of the screen, you'll have the concept, and you click on that, and you can find all the details of what you're looking at. So that's just the way to make a completely self-documenting world. Now I jump here to a language for children, because you'd want this system to work for children. And this is a language, Scratch, that is 12-year-olds love. They do their robotics in it. They do video games in the Scratch language. 78 million kids around the world have learned the Scratch language. It comes out of MIT, but it's been translated into the Thai language and the Japanese language, all the other languages. So anyway, children really ought to have access to the way the structured knowledge world is formed. Well, I just put this thing up because he went into the computer. I think we're all going into the computer, is my thinking here. And we're going to all be able to go into the computer, walk around, and see everything. If we want to. I mean, most of us just want the surface knowledge, right? But well, John Backus was the inventor of Fortran, and it meant formula translation. And we can see this is the mathematical expression. Here's the way that it's represented in any computer language today. It pretty much follows the lead of Fortran, which invented this format. Well, it means we got two different pictorial languages for mathematics and computing. Why don't we all use this language? That could be considered an assignment statement, right? We would have slightly different semantics. It doesn't mean C is equal to square root of A squared plus B squared. It means C is given the value that comes after that expression is evaluated. That would be the interpretation in a computer language. So why don't we do everything using mathematical language, at least the pictures of math? Then kids would simultaneously learn how to do algebra and do mathematics, and the editor would correctly compose the expressions. So you wouldn't have to be doing erasing and rewriting. I remember doing my mathematics, and I would have to erase all the time and rewrite the formula because I needed more space inside the parenthesis. So if you had an editor that took care of that, we'd be quite a step ahead. Well, anyway, Professor Frink demands units. And I ran into Professor Frink on the internet. And Professor Frink has a language named after him, which handles units. It's the only computing language that handles units. And Professor Frink had this long quote. John Soa, actually the guy behind it. Frink is designed to make physical calculations simple, to help ensure that answers come out right, and to make a tool that's really useful in the real world. It tracks units of measures, feet, meters, kilograms, watts, etc., through all calculations, allowing you to mix units of measures transparently, and helps you easily verify that your answers make sense. Well, if we had used a language with units when we send the Mars rover to Mars, and we got successfully through the interplanetary calculations, and we go into the descent mode, switch programs from interplanetary to the Mars model, And it turns out that they used the metric system to get to Mars, but to get down, it was in the imperial system, and we lost that Mars rover. So we ought to have units everywhere, right? Well, anyway, it turns out that at least in my, I just am I guess a researcher. I find that you can really think of units as being a concept. You might have the concept of a person, and a name, age, sex, race, whatever. And so you have a table or a list of people. And then you apply the average function to it. You're going to get the average years per person as the units automatically, because that was the list of people, right? So I think it would do a lot of what John Solis said, make sure that things come out consistent. And it wouldn't, I remember when I was working on SAS and we decided to do graphics, we had to add a label statement in for every variable so that you could annotate the axis of the thing. But if you had the units in with the name object, which would have the long title, then you could automatically label your axis on any report that you did and your data analysis. And you actually have to preload AMOR with the concept of what a gram, a liter, and a meter is. But the way I've defined a number is every number has a unit attached to it, so you can't get around it. And the way I would think that the editor would work is you would see the number, and you move the cursor over there, and then the units would pop out at you, so that you could always see what the units are of the number you're looking at. Well, unification is a big thing in the world. And I actually went and looked up in my, I did a Google thing for churches in Gainesville with unity in its title. And there was probably 12 of them. And I actually thought it was amazing if you think about the Moonies were the Unification Church. So it is a holy grail, is unification. So if we, and there's a fellow, E.O. Wilson, who's a philosopher of science who just died, and his last book was called Consilience, which was the unity of knowledge. So he was a big believer that we ought to bring all the knowledge together. And I actually just opened up his book just before I came here, and just to see what the preface said, but he talked about his early growing up in Mississippi and how he was just in love with nature. And when he learned about the taxonomy of the species, he just loved that. I mean, he just thought how you could go from the general to the more specific and define every last little organism very precisely in this big taxonomy. Well, I would like to unify philosophy, the theory of the mind, language. Language is really phrase, case, and list, which if you go back to my concept of a concept and compare that to the BNF, it looks pretty much the same. They got the phrase, case, and list in the BNF. And obviously, to return to using pictures for algebraic concepts, and this is not exactly unification, but logic would be, the set theory would be in there. And this is a peculiar thing with my research. I invented the decision table as a instruction inside of AMOR. And then I look at the unified modeling language, and that was a real big thing about 15 years ago. And I look in there, and they had decision tables, just the same as I had them. Well, almost the same anyway. But so I didn't have an original idea then. But anyway, the AMOR thing is a big knowledge graph. And that is, I had a visitor who had worked on Alexa. He said, "You're using the same structure we use for Alexa." And what was incredibly revealing, I said, I wasn't sure what I was going to do when I got down to the letter A and B, or even true and false, or even, characters. He said, "When Alexa, we treated every last thing as a concept." I'm not so sure he called it a concept, but essentially that was it. And then I thought, well, look at Wikipedia, how they treat letters in Wikipedia. And they had the concept of a word, and they have the concept of A, B, C, and they have it in every language of the world, 2 pages for every character. Tell you when it was first used, 2,000 years ago, and how it's changed through the course of time and whatever. So you can really get quite detailed with your concepts. Well, anyway, I threw in this theory of the mind, and I'll mention it at the end of the talk for a little bit, but that is a sub-area of philosophy, and I think that this concept connection is an incredibly good alternative to the theory of the mind, because they were hypothesizing a language. This guy Jakoff was a mental language where we transmitted thoughts. I don't know why we can't just talk about concepts in our mind. Anyway, this is a new computer theory in my mind. I hope the only way I think people will believe it is if I have a working model. So I'm working towards that. But I think I have to have a good description of what I want people to do first. So that's where I'm at. Anyway, I'll just jump on. So here's the world. We gave it a name, and its parent is concept, and then we nailed its definition right there. We nailed it. The connection is right at the conceptual world. You can jump into the world right here, and so inside the variables inside the world are the people, organizations, education, and government. Well, I thought, well, I ought to be prepared for AI questions, so I went and did a little search for AI. And it turns out right today in San Francisco, there's a conference called AI Plus Data, which I think that's what we're talking about here today. Maybe you don't realize it, but I think that's what we're talking about. And there's a company that has this book. And it turns out that the way knowledge graphs are stored, they're quite often stored in what they call data lakes, which amounts to being, well, I guess we could use the lake metaphor. There's a lot of ships, little objects inside the lake. If the lake gets too full, they break it into 3 lakes and move the objects around, and they can expand infinitely the conceptual world with these lakes inside of lakes. And Amazon Web Services sells data lakes, and I believe there's several other vendors that are selling data lake services. So this company brought out the data lake platform for dummies to introduce their product. I thought this was an unusual marketing tool, but this is straight from Amazon's website, the Amazon Knowledge Graph, and it just showed the relationships with various concepts. Oh, it's like a concept map. Now, Victoria Fromkin has a big place in I'm fond of her. In 1973, she published in Scientific American an article that I read, which I've remembered since that date. And she described how we communicate. And so we have something we want to express, and so we have to break it down into sentences. Then we have the first sentence of our paragraph that we're going to say. So we have to pull out the subject, verb, and object. We're actually building we're using the concept of a sentence, and we're building an object of a sentence in our mind, a little tree. It's called a parse tree usually, but I'll call it a concept tree. So it's subject, verb, object. Then we have to get some articles, adjectives in there, and get everything together. Then we have to serialize it. Then we have the first word we speak. We have to take that word and break it down into syllables. And we break it down into phonemes. We speak the phonemes. And then the listener's got to take the phoneme in. And then when he hears the break between the words, he's got to put the phonemes back into, he's got to put them into syllables, then he's got to put the syllables back into words. At the end of the sentence, he's got to build the tree structure in his mind, subject, verb, object. He's got to have the same tree structure that the speaker had, the concept of a sentence, an object of the concept of a sentence. He's got to have the same thing in his mind, and that's how we transfer knowledge. Now, we've listened, we got the sentence in our mind, defined by the concept of a sentence and the object of a sentence, or sentence object. Then we have to take that sentence object and update our database, our mind. So isn't the mind similarly constructed as the same tree? And that pretty much is the big thought here. Anyway, what did I do? Oh, here I did it. And this is my acknowledgments. So that's my end of my talk, and I'd like to hear questions. Did you understand? Okay.
Hey, Tony, some cultures don't share concepts, and I'm not multicultural. I'm not. I have traveled two parts of the world, but not extensively. But I've heard that, and I don't know if this is apocryphal, but one of his parents were from Cambodia, and he realized that they didn't have a concept for future. And he realized that his parents, even in their personal communications, had never really discussed the future. And so I was just wondering, how would you accommodate that in a sort of a knowledge tree of knowledge trees for all humanity? Would you then, would that be a way to teach new concepts to people who had never conceived of those concepts, or would that be a problem, just for a more, in that, you could never quite get all cultures and all people to agree on what a concept is, or whether it even exists for that matter?
Well, And if you were in Russia, you would have your own a model of reality. You wouldn't want to use the American model of reality. That's pretty much what I would think. You'd create your own, is what I would think. Now, Cambodia is a basket case. So I think that they would just have to learn English. I'm here.
Up
Yes.
front. Wait for the microphone.
Hi, I'm thrilled that you were involved in SAS.
Thank you.
I was in Procter & Gamble in engineering, and we had SAS converted to our Macintoshes, and we did great work. And baby diapers are better because of SAS. and the thinking that you brought after you took that foundation in SAS has been amazing.
Thank you.
I'm thinking right now how to take IHMC's concept maps now and more rigorously apply them to other areas. So I appreciate that.
Thank you.
Any other questions? Well then, oh, there's one there.
Thank you. And good evening. And very impressive background. I find it quite interesting. I was actually looking up SAS earlier today when I was at work, and I'm a student in project management, and I see how SAS kind of ties in some of those big software database companies like Oracle and some others. And just listening, it's just very, very interesting. I'm kind of a techie guy, so this might be a little bit off the subject, but just wondering, how do you feel that our civilization is going to be very dependent on AI moving forward? I recently became a drone pilot, like leisurely, and I do a lot of research on that, and I see how big companies like Amazon, they also have a cloud system, AWS.
Sure.
Right? These big companies, right? And how do you think that we're going to become too dependent on AI moving forward, and how, do you think that's going to be beneficial or crippling?
Well, this is out of my normal domain, but AI's going to be with us, and it'll be a tool. They say it's going to hurt the young lawyers because they won't have to do the legal research anymore, but I'm not a futurist in that. I don't think I'm the right person to ask.
On that note, let's thank our speaker.